Consistency Protocol, Continuous Consistency. I am Mrs. Kavita S. Replication in distributed systems. Replication is the process of maintaining the data at multiple computers. Replication is necessary for improving performance. A client can access the replicated copy of the data that is near to its location. 2. Increasing the availability of services. Replication can mask failures such as server crashes and network disconnection. 3. Enhancing the scalability of the system. Requests to the data can be distributed to many servers which contain replicated copies of the data. 4. Securing against malicious attacks. Even if some replicas are malicious, secure data can be guaranteed to the client by relying on the replicated copies at the non-compromised servers. Introduction to consistency and replication. In a distributed system, shared data is typically stored in distributed shared memory, distributed databases, or distributed file systems. The storage can be distributed across multiple computers. Simply, we refer to a series of such data storage units as data stores. Multiple processes can access shared data by accessing any replica on the data store. Processes generally perform read and write operations on the replicas. Distributed data store is shown and there are 3 processes. Why consistency? In a distributed systems with replicated data, one of the main problems is keeping the data consistent. An example, in an e-commerce application, the bank database has been replicated across 2 servers. Maintaining consistency of the replicated data is a challenge. 2 replicated databases are shown here. Balance is 1000 in both the databases. Now just observe this. So now you can see that balance in both the replicated databases are different. One is 2100 and second one is 2050. Maintaining consistency of the replicated data. So here in the data store, n replicated copies are there. Each is having the variable x with the value 0. There are 3 processes. So process 1 is reading the value x from replica 2. R of x 0. It means that read the value of x, read the variable x, and the value read will be 0. Now observe this. Meaning is that process 1 is updating the value of x to be 2. So now the replica 1 is having the value of x as 2. So now process 3 is updating the value of x to be 5. Okay. So strict consistency. In strict consistency, the data will be always fresh. After a write operation, the update is propagated to all the replicas. A read operation will result in reading the most recent write. If there are occasional writes and reads, this leads to large overheads. Another form of consistency is loose consistency. So here data might be stale. A read operation may result in reading a value that was written long back. Replicas are generally out of sync. Replicas may sync at coarse-grained time, thus reducing the overhead. Consistency model. A consistency model is a contract between the process that wants to use the data and the replicated data repository. Consistency model states the level of consistency provided by the data store to the processes while reading and writing data. Continuous consistency model. In replicated stores, there should be a mechanism to measure how inconsistent the data might be on different replicas, how replicas and applications can specify the tolerable inconsistency levels. Consistency specification models enable measuring and specifying the level of inconsistency in a replicated data store. Continuous consistency model is a type of consistency specification model, and it is used to measure inconsistencies and express what inconsistencies can be expected in the system. Continuous consistency in distributed systems refers to a model where the system maintains a certain degree of consistency at all times, but it does not require absolute or strict consistency. Instead of enforcing strong consistency, where all replicas of data are always synchronized, continuous consistency allows for bounded deviations in terms of consistency, latency, or divergence. Continuous consistency characterized by three independent axes. They are: 1. Numerical deviation. Deviation in the numerical values between replicas. Example, 2 copies of a stock price should not deviate by more than $0.02. Second one is order deviation. Deviation with respect to the ordering of update operations. Example, in a bulletin board application, a maximum of 6 messages can be issued out of order. Third one is staleness deviation. Deviation in the staleness between replicas. Example, weather data should not be more than 4 hours stale. That is, the system allows data replicas to become stale but ensures that the staleness remains within a predefined limit. For example, a read operation might return a slightly outdated value, but the staleness of the value is guaranteed not to exceed a certain time or version threshold. These are the references used for the contents of this video. Thank you.